Hello and welcome everyone to this session. Just a quick note, the session is pre-recorded, so it's going to be a 10-minute video, after which we will go to the live Q&A session. So for now, enjoy the video.
Welcome everybody. Today's session is an overview of our experiences in mapping clinical data to FHIR in real hospital environments. I'm Razvan, Dinu, software architect in cardiology informatics within Philips Healthcare, the Netherlands. A little bit about our cardiology informatics world. We are developing applications supporting the echo and interventional cath lab workflows, and in general innovative clinical applications for cardiac care. Now, when you think about cardiology, you probably think about images of the heart, but in recent times, cardiology informatics has become much more than just images data. As you'll see in our presentation, there is lots of discrete data being produced and used by our applications. Looking at our clinical applications, we noticed a pattern. First, as I mentioned, there is a lot of data needed. This comes via an inbound pipeline and is stored in a central data storage. Think of patient data coming from an EMR or a HIS, lab results, data from devices such as pacemakers or vital measuring devices. Second, once the data is stored, we want to be able to use it in our applications. This can mean simple visualization or more complex use in algorithms. Furthermore, our applications might need to add extra data to the data storage. And last, the data rarely stays confined in the storage. It needs to be exported via outbound pipelines to various destinations, such as the EMR, regulatory bodies known as registries, or hospital billing systems. One thing that we see for all these blocks is they need to handle various degrees of customization or configurations, various data types, various data formats, various coding systems, being per hospital or within the same hospital, per region or per country. Now, what we certainly wanted to avoid is creating specific solutions for each of these variations. We are looking for a generic solution that can be customized, not for custom solutions for each of these data variations. Considering this, we quickly decided that having a stable central clinical model on which our applications can work is essential. Working model base is also essential. We want to do most of the custom changes in the model, not in the code. The transformations to and from this internal model should be solved in the interoperability layer, not in the clinical applications layer. We also quickly decided that FHIR is the best choice for a standard on which you can develop the clinical model. I hope I do not need to advertise FHIR to this audience, but I'm happy to share our experiences in making this choice. It also became quickly clear that we needed a form of external modeling and the mappings to the internal model. This in order to be able to use the same model-based principles in the interoperability and avoid having to hard code the inbound and the outbound pipelines. So we went for FHIR, but then we started to look at real hospital environments, and there the term FHIR, although more and more present, is still very rare. Just look at this concrete example. In a real ecosystem, data is still in HO7, DICOM-SR, or even specific forms of XML. It uses specific coding systems, so standard coding systems like Loink and SNOMED are more and more used. For the same data type, you might find different formats, different codings, even within the same region. And the same holds for the outbound, where each receiving party has its own specific format and coding. So one thing became clear. We did not solve all our interoperability issues by choosing FHIR. FHIR offered us a starting base for our clinical applications, but we needed flexible transformations from various formats to FHIR and the other way around if we were to succeed. And here are the main lessons learned. Creating a generic mapping engine capable of transforming data in various formats to a FHIR-based clinical model is significant effort, but it is the best way forward towards achieving clinical interoperability. Customizable to real hospital environments, and this is essential. We do not want to solve the interoperability problem per hospital again and again by spending months of development effort. We want flexibility, we want customization. We want to be able to go to a hospital, analyze the data, and be able to connect the systems and use the data by just modeling the sources and destinations and mapping them to our internal model. So let's look deeper into this. We have two separate problems. First, the syntax transformation. As I've said, in general, the syntaxes are well defined by standards, like HO7 version 2 or DICOM-SR. But sometimes the vendors choose to take advantage of the standard's flexibility, and there are also specific formats that might be used. So the syntax transformation needs to take this into account. It needs to be able to correct vendor-specific syntax problems. This is in general technical transformation, and no clinical validation is needed. It is driven by vendor specifications. The second transformation is a semantical one, and this is where clinical knowledge comes into place. Is the heart rate measured by your device the same as the heart rate we expect in our clinical model? or more technically said, is a code in LOINC equivalent to that code in our internal clinical model. And this is driven by the model and the mappings between external and internal. And here what we learned was it is easier to focus on the actual semantical mapping when the syntax is well defined. It is easier to focus on one common syntax than to deal with every specific variation that vendors might have. So how did we solve this? We took a two-step approach. First, as I've said, the syntax mapping. By using a combination of format transformations and a preprocessor, we brought various vendor syntaxes to a normalized XML syntax. This means that supporting a new vendor is in principle just a matter of adding a vendor specification in the form of, for example, an XSLT. Now, this might sound simple, but everybody that works with SSLTs know that is anything but simple. And yes, this is effort that needs to happen once per vendor and needs to be maintained. But you can correct the syntax by specification only, and this is a big advantage. And then the real problem, the semantics. We quickly came to the conclusion that it is possible, but to create a full transformation engine is significant development effort. But hopefully this pays off when you can customize your interoperability pipelines by just changing the models. And again, you can do this step by step. Finally, you'll end up with a complete model-based semantical transformation. And by the way, this is an example for the inbound, but you can imagine a symmetrical outbound transformation from FHIR to a specific format working in a similar way. So how does it work in practice? Here an example of transforming an HO7 heart rate message in a specific MDIL coding into FHIR observation in the internal model using an internally chosen coding. So first, the syntax transformation, which creates a structured XML, but keeps all the semantics in the external source. Then we have an external model for this source. In this case, we use the MDIL codings, but as you can see, the external model contains in principle more specific vendor observation codes, LOINC codes, unit codes, because we should not forget that not only the observation codes are coded, but also the units interpretations and so on. In the simplest form, the external model is a collection of value sets. In complex cases, we really need to model just as in the internal model, but I will not go into details here. The actual transformation works with concept maps. So it will take the code for the heart rate in MDIL, and it will try to find the concept map to a Philips heart rate, and similarly for all the other codes. And then based on the codes it finds, it needs to look for a specific structure to create. In this case, we are looking for an observation, and it will create an observation with all the internal codes filled in. One thing we learned here, the model seems simple as a concept, but when you start adding supported vendors and data types, things get more and more complex. So yes, once the transformation is in place, it will save development time, but modeling is also complex. Ideally, you want to generalize things and group models, not by vendors, but by coding systems, such that in the future, if a vendor comes in and says that it supports LOINC, you are ready basically, just by using the syntax transformation, you are ready to actually support that vendor. So I hope the idea is clear. Instead of hard coding the pipelines, you work with a FHIR-based clinical model, an external model, an internal model, and the mappings between the two. All FHIR-based, all powered by FHIR. One thing I really want to mention as a lessons learned is the risk of over-modeling. We started, of course, by creating a profile for everything and defining internal codes. Pretty soon we realized that the base FHIR profiles are most of the times good enough. All we need is to restrict codes, and then we are good to go. This doesn't mean that you should not profile. There are places where the base resources are too generic. But even there, the question is, how deep do you want to go into profiling? And then the codes. If we define an internal code for everything, we always need a mapping. And mapping, as we've seen, are expensive. If 80% of the world is using LOINC for labs, maybe it's a good idea to use also LOINC in an internal model. And again, sometimes complexity is unavoidable, and there might be a need for complex mappings. And there are not so many out-of-the-box execution engines out there for mappings. This is something that we hope it will change in the future. So to summarize, interoperability is difficult, and FHIR certainly helps. But FHIR is not going to solve all the problems. Choosing FHIR as a basis for our model-based approach proved to be a good decision. But we do need also syntax and semantical mapping engines to support interoperability, and making those model-based is significant work, but it is the only way forward if you want to be flexible in real hospital environments. If you want to be able to react fast to new vendors being added, vendors changing specs, customization requests, regulatory bodies changing requirements. These are our lessons learned. Feel free to contact me via the normal routes. And now I will open for Q&A.
All right. Thank you very much for your super condensed video. A lot of information. How did you manage to put this much in? It's crazy.
Yeah, exactly. Yeah, it was a challenge, I must admit. So that's why I can imagine that there was quite a lot of information condensed in these 10 minutes. Yeah, we did quite a lot in these years, and we had a lot of lessons learned. So that's something that let's say I wanted to share as much as possible. And I think the main message is we are trying to build, let's say, a generic engine that can be customized to different situations. And it can work, let's say, for a vendor, it can work for a different vendor also by just adjusting everything and creating, let's say, a new model and some mapping. So I think that was the main goal for us. So to be able to respond quicker to, let's say, hospitals changing requirements, to vendors being added, vendors being removed, regulatory bodies changing requirements, and so on. And yeah, the conclusion was that it's significant work. It's possible to do it. It will take some time, and it needs to be, of course, maintained over the years. But it is possible. Of course, if you let's say invest a lot in these engines. And I hope that in the future, more and more, let's say, third parties and more and more, let's say, mapping engines will become available, so that you can actually just plug and play some of this into your pipelines. I think that will be a nice evolution for this. So
That's great.
I'm not sure if there are any questions.
Not yet. Most of the time, it takes some time to come up with a well-formulated question. So we gotta give them some time. I was actually wondering. You said sometimes complexity in a model cannot be avoided unless it's added to the mappings. It's part of the beware of the risk of overmodeling. But how do you deal with the complexity then? How do you make sure that the complexity doesn't get too complex and that you can no longer use the model?
Yeah, so that's always the risk. So I like the term over modeling because we let's say we faced it a few times. So when you start with a model, you are very excited. You say, okay, I'm going to model everything. I'm going to create my own codes. I'm going to create a very specific company model and all. Yeah, everything leads, let's say, to if you define internal codes for everything, you always need to add mappings. And mappings can be simple, but can also be complex. And the mapping engine, as I've said, it's very complex to maintain. So if you can avoid mappings, you should avoid that. That being said, I think there are situations where you actually cannot avoid. And one situation is where, let's say, there is not a predefined industry standard, industry coding system for a certain let's say type of clinical data, and there you need probably to define your own code, because otherwise your applications will need to work on 10 different coding systems. So yeah, you cannot avoid. And yeah, the only way to handle complexity in mappings is to develop a good mapping engine that can actually execute those mappings.
Yeah, actually, this connects to a session I had before. There was a question: what is a good tool to use for mapping? Maybe you can share what you're using, or
yeah,
so
we do have some let's say internal tooling for this, but in principle, if you let's say if you work with concept maps only, I mean any text editor will do. You just need an example of a concept map, and then you can just do it for defining the mappings. For executing the mappings, it's all for us, all internal. So it's we don't, let's say, have a third-party execution engine. So I think your question was more about, let's say, defining the mappings, and in that sense, I think you can use, let's say, standard tools as a simplifier, or you can use a text editor, just copy paste in the JSON and just modifying it. Or as I've said, yeah, we have our own internal tools. I think those are also quite nice.
All right, great. Is there anything you want to share on your screen? Maybe was a graph or a lesson learned that you still want to specify more? I will stop, or yes. I stop sharing my screen so you can show it yourself.
So let's see. So I think it's just it's mostly, let's say, our main lesson learned. So I think, as I've said before, we are looking for a generic mapping engine. It takes time to create one. We want to work FHIR-based because that's let's say normal evolution we see, and we see a lot of advantages of working FHIR-based. it is significant effort because when you go to a hospital, of course, you've seen in my slides, you face a situation where the hospital already has integrations with HL7 version 2, DICOM-SR coming. You have XML, specific XML. So you will need to handle those mappings, and there is a syntax transformation, which is just, let's say, HL7 version 2 to FHIR, but there is also the semantical transformation, which is just taking into account, let's say, specific vendor codes and mapping them to what you would want to use into your application. And if you make everything customizable such that you don't need to, let's say, rewrite everything every time you go to a new hospital, every time you want to support a new vendor, I think that's the way forward. So I think for us, this was our lessons learned. Is it a lot of effort? Yeah, it is significant effort. So you should not underestimate it. Yeah.
A lot of questions came in. That's good. We have 5 questions now. So let me just start at the top. To help semantic sense checking of the collated data in the finished FHIR repo, did you use or build any tools?
We do have some internal tools for this, but I must say that yeah, in principle we are not using tools for this, I think.
All right. Next question. Thinking about the actual mapping of existing models to FHIR, what have you learned between doing the first mapping and doing it now? Any advice for people just starting to map their own internal models to FHIR?
Yeah, so it's what I've said. So I think you should do 2 things. You should separate first the syntax from the semantics. I think that's very important. So try to understand what is syntax and what is just a technical transformation from your own model, let's say, to FHIR. So if you have, let's say, the models in XML or HL7 or DICOM-SR, just focus on how to transform that to FHIR structures. And the second part is a semantical transformation. So think about your coding systems that you use internally. And there, the lessons learned that we've had is reconsider a bit, let's say, your internal coding systems. Do you really need to use something specific, or can you work with something more standard like Loink or SNOMED and so on? Because it will save you a lot of, let's say, mapping effort. Just adopting, let's say, a standard system that the coding system that is used by 80% of the market, it will save you a lot of effort.
All right, clear answer. Thank you very much. Next question. Did you have a clinician input into your model? If so, how much was needed to help build the model?
Yes, and it was
a lot of
needed
time.
a lot. Yeah. So it's remember, it's a clinical model. So you need to understand, if you look at the heart rate code, yeah, there are in Loink, I think there are, I don't know, 80 types of heart rate codes. So you need, as a technician, I mean. As a technical guy, I don't know what the differences are between all those 80 codes. So you need really clinical input to actually analyze and to see if your mappings are correct. Did I map, let's say, heart rate measured by, I don't know, by one device to the heart rate that I really want in my application? I think that's something that you always need, and it's very nice. And that's where tooling can help. If you have tools that can help clinicians actually review those mappings. So yeah, right. it is a significant clinical reviewing effort, actually.
Yeah, it's never wrong to get the other domain involved as well.
Yeah.
Next question: do you provide the XLST mapping for syntax layer with the vendor, or give specifications to the vendor to do it themselves?
It's the other way around. So the vendors give us a specification, and we are let's say constructing the XSLTs. Of course, in the future, you might wonder if you also go that route, that you say like, okay, you can tell to the hospital, just plug in your specification, or you can tell to a vendor if you want to. For now, I think we are developing also the XSLTs. So the vendors provide us a specification of their syntax, and we are constructing the XSLTs.
All right, great. There's one more question, and we only have time for one more question, so that's great. Wait, this question is 2 parts. First, is this mapping engine meant for migrating legacy data or ingesting data in real-ish time?
In principle, it's not meant for ingesting data in real time. You might use it there, but then yeah, you have to be careful about the performance. It can be used also for legacy. I think it's just the main goal for us is to actually use it in a real hospital environment. So yeah, do you consider HL7 version 2 legacy or not? Yeah, I think at this moment we cannot consider it legacy because it's still used by 90% of the hospitals. So it's just for use for transforming real data, not necessarily legacy. Yeah, you could use it also for legacy, but that's a side.
All right, that's not the main
No.
goal. All right, then the last part of the question, we just finish it. Once the once the data is transformed to FHIR, how do you get the data into the FHIR server, or do you use bulk upload or via the REST, or how do you do it?
Yeah, you can do all of this. I think REST calls are okay. You can do reconciliation and then REST. I think that's the standard pattern there.
All right, great, thanks. Well, then there rest me nothing but to thank you for your time and your clear presentation, and enjoy the rest of DevDays.
Yeah, thank you very much.